If geography is the study of the earth, then the foundation of geography must be the study and understanding of soil. What it is, what the different types of it are, and how humans have learned to use it and protect it.
What is soil?
Soil is a layer of organic and mineral material that covers most of the land surface of the earth. It is one of the most important natural resources we have. Civilizations depend on the quality of their soils to grow their food supplies. Soil has served as a natural filter to purify our underground water supplies. Our planet's soil is constantly changing. It is created by the slow, continuous physical and chemical breakdown of rock and the decayed remains of organisms that were once alive. Besides the basic rock material, soil usually contains plant roots, plant and animal remains, living animals such as earthworms and insects, and other living organisms such as bacteria and fungi, air, water, and minerals obtained from the weathering of rock material. Only the top layer of soil, which we call topsoil, can adequately support plant life. In most places, topsoil is only about 6 inches deep. It takes nature about 500 to 1,000 years to replace 1 inch of topsoil.
What are some important terms we should know when we talk about soil?
There are several words frequently associated with the topic of soil that we should explore before beginning a more detailed discussion of this topic. They include soil horizons, leaching, arable, silt, floodplains, alluvial soils, loess, humus, and loam. A soil horizon is a distinct soil layer with more or less well-defined characteristics. You can usually see these layers if you look at a cross-section of these layers called a soil profile. There are 3 main soil horizons. Horizon A is the topsoil, which contains humus and decaying material. Horizon B is the second level, where materials leached from Horizon A can accumulate. Horizon C is the bedrock or parent material of the soil. Color and texture of soils also help to distinguish one type of soil from another. Leaching is the process whereby water removes minerals from the topsoil or upper layers of a rock or ore. They can be filtered down into the lower layers of the soil or washed away completely. This can result in soil becoming infertile. This means the soil is not arable. Arable means that the land is capable of being cultivated or that it can grow crops. The soil must have some mineral content in order for crops to grow. What crops can be grown depends on what type of minerals are present in the soil and in what amount these minerals exist. Silt refers to a type of solid matter called sediment that water, ice, and wind transport and deposit. It's made of particles of rock and minerals. These particles are smaller than fine sand and larger than particles of clay. Soil is called silt if its silt content is greater than approximately 80%. Deposits of silt slowly fill in wetlands and other bodies of water. Floods deposit silt along riverbanks and floodplains. Floodplains are flat areas along the sides of rivers and streams that are susceptible to flooding. Some are quite large. The Mississippi River's floodplain is about 80 miles wide in some areas. At the mouth of rivers, silt may accumulate and create deltas. These deltas are new areas of land. 3 of the biggest are at the mouths of the Mississippi, Nile, and Amazon River. Alluvial soil, or alluvium, is made up of gravel, sand, silt, and clay. It's a loose material when brought down by a river and deposited in a riverbed or on a floodplain. This helps to create the deltas. Alluvium also filters into and builds up the bottoms of lakes and estuaries. Alluvial soil is rich in mineral content and forms some of the most fertile soils in the world. Loess is a fine, mineral-rich material that is composed of dust and silt. Often, it is simply called wind-blown silt, but it can also consist of dust created when glaciers grind rocks into a fine powder. It often accumulates at the edges of deserts. Loess usually is several inches thick, but it can accumulate up to 100 feet in thickness in some areas. Humus is a dark, thick, soft, and spongy organic material that helps to increase a soil's fertility. It develops as plant and animal matter decomposes. The decomposition is caused by microscopic bacteria and fungi in the soil. These microorganisms thrive when matter decays, and they in turn produce nitrogen, which is an important nutrient for most plants. Loam is a mixture of varying amounts of sand, silt, and clay. Soils with a high content of loam are easy to cultivate and retain moisture well, and because of these characteristics are considered among the best soils in the world. All soils have four things in common: minerals, organic material, water, and air. The exact combination of these four materials helps to make one type of soil different from another.
What kind of soils can be found on Earth?
Pedologists, or soil scientists, have classified soils into 10 major categories. Each type of soil can be found in various places around the world. Each, with its often distinct characteristics, has different combinations of the elements found in all soils. Some are rich in nutrients, some are not. Some are found in moist climates, while others are located in drier regions. Some are more developed than others. This means you can usually see the different horizons. They've had time to break down the particles of rock. Less developed soil means that they are newer soils. Let's now take a look at these 10 different soils. Alpha soils develop under forests and grasslands in mild, humid climates. Crops can grow easily in these soils. Alpha soils can be found in the northern European plain, the Sahel region of North Africa, in eastern India, and in the southern parts of the Great Lakes region in the United States, where cherries and cranberries are grown. Aridosols occur in dry or desert regions. They contain small amounts of organic material and are light-colored and sandy in texture. With water sources available, these soils can grow crops. It can be found in such areas as Kazakhstan in Central Asia, where cotton is grown, and desert regions such as North Africa and the American Southwest, where grasses can be grown for grazing. Entosols show little development and closely resemble the parent bedrock material. They are found in recently exposed surfaces such as floodplains and sandhills. Entosols can be found in Southeast Africa, where millet and cassava are grown, and on the Iberian Peninsula, where wheat, some types of fruits and vegetables, plus olive trees are cultivated. Histosols are acetic organic soils. These soils are typified by swamps and bogs and other water-saturated places that do not drain well. Bogs are regions that have poor drainage and where dead plants do not decompose or decay quickly. This type of soil can be found in the region just south of Hudson Bay in Canada. Inceptisols are slightly developed soils that can be found on former valley floodplains and stable land surfaces, in which soil layers are developing. This means that they are young soils. These soils are found in northern Canada and northern Russia, bordering the Arctic Ocean. You'll find a tundra type of vegetation here, such as mosses and lichens. It's too cold here to grow crops. Mollisols occur in prairie regions. They have organically rich topsoils with lots of humus. Chernozem, a Russian term for meaning black earth, is this type of soil. This is considered one of the best soils for growing crops. Mollisols can be found in the Great Plains region of the U.S., in northeastern Argentina, in central Turkey, and in the steppe region of Asia. These soils are good for producing wheat and other grain crops. Oxisols are the most chemically weathered soils. They occur in warm tropical regions and are reddish in color. Nutrients have been leached out of them, and they have a subsurface layer full of iron and aluminum. Oxisols can be found in the tropical regions of South America and Central Africa. Bananas, yams, sweet potatoes, and oil palms are grown in these soils. Spodosols, similar to oxisols because of high iron and aluminum content in the layer beneath the topsoil, are associated with cool and humid regions. Their subsurface layer, or horizon B, is rich in organic material which has been leached from the topsoil. Spodosols exist in eastern Canada and much of Sweden, where they support major timber crops, such as spruce trees. Ultisols are moist, acidic, well-developed soils that can be found in warm, humid climates. They have a light-colored surface layer and a reddish clay subsurface layer full of iron and aluminum. Ultisols are found in warm, humid climates, such as the southeastern United States, where cotton, watermelon, and tobacco are grown, southeastern China, where yams, tea, and rice are grown, and the wheat-producing regions of southern Brazil. Vertisols form in a climate that has alternating wet and dry seasons. Deep, wide cracks develop during these dry seasons because the soil shrinks when it's dry. These soils are fertile but hard to farm because of the texture of the soil. Vertisols exist in India and the Great Dividing Range of eastern Australia, and support grains such as wheat and grasses grown for grazing.
What is erosion?
Erosion is the process of wearing away the land surface by natural agents and the removal of the rock debris and soil. There are four major agents or causes of erosion. They are primarily water and wind, but also ice and gravity. Water erosion can happen in several ways. One type of water erosion is splash erosion. This is when the soil is washed away by the direct battering of rain. Rill erosion takes place when small channels are dug into the soil by water runoff. When rills come together and form larger channels, this can be called gully erosion. Sheet erosion occurs when thin layers of level land are washed away. On a larger level, we can see where rivers and streams carve valleys as they move along. Wind can hurl sand and other material against rocks and blow the topsoil from one place to another. Soil that is unprotected by plants and ground cover can be blown away. Dust storms are an excellent indication that wind erosion is taking place. Glaciers can widen and deepen valleys that already exist. Gravity and heavy rains or snow can cause landslides and avalanches. Another term to be identified at this time is weathering. This refers to the chemical, mechanical, or organic processes by which rocks are decomposed or broken up into smaller particles. Weathering can occur chemically, as when rainwater containing carbon dioxide dissolves limestone. Or it can happen mechanically, as when changing temperatures cause rocks to expand and contract, making them eventually crack and break apart. Organic weathering can occur when acids produced by plants such as mosses rot the rocks.
What is soil conservation?
Soil conservation is the effort to reduce the erosion of our topsoil and to maintain the fertility of our soils. Farmers make use of a variety of conservation techniques. One is contour plowing. This involves plowing and planting crops around a hillside instead of straight up and down the hill. The curved furrows catch the rainfall and allow most of it to soak into the ground. The furrows can also catch soil that is washing down from the higher part of the hill. Strip cropping is another method employed by farmers. They plant close-growing plants such as clover or grasses in between row crops such as corn or soybeans. The clover or grasses hold the water and keep it from eroding the soil from the other rows. Terracing is used in many parts of the world where the land is very hilly or even mountainous. Small level patches are cut into the slopes, and walls or mud banks are built up to help keep the soil and water from being washed away. On treeless plains, shelter belts or wind belts are planted. These are trees planted at the edges of the field that are used to break the force of the winds that move across the area. They reduce the amount of wind erosion that might take place. Crop rotation is another good conservation method. By planting different crops each year on a piece of land, farmers can keep the soil productive. Nitrogen, an element needed for plant growth, can be added to the soil by planting crops like clover, alfalfa, and soybeans. After a year or two, these crops can be plowed under. This is called green manuring. Cover crops are also a good way to maintain the soil. The land is always covered by a growing crop or with the remains of a crop already harvested. The remains can be plowed under before the next crop is to be planted. This helps to increase the fertility of the field and also improve its water retention capability. Other ways to reduce soil erosion away from the cultivated regions of the world include replanting trees in forested areas and reducing the number of livestock per acre on our grasslands. Too many animals eat too much of the grasses, and this leaves the soil exposed to erosion. As we have seen, what we think of as plain old mud or dirt is actually a complex and mysterious material essential to all our lives. The history of civilization has depended partially on our understanding of soil. This understanding is also just as important for future generations.